A 12-metre ladder leans against a brick wall. If the foot of the ladder is 5 metres from the base of the wall, how high up the wall will the ladder reach? A diagram may be useful. So if that's the wall and that's the ground, and here's the ladder down here, we know that the ladder is 12 metres. We also know that the foot of the ladder here is 5 metres from the base of the wall. We're after h, and we can see that we can use Pythagoras' theorem. H squared plus 5 squared equals 12 squared. So h squared is 12 squared minus 5 squared. Don't forget, once you've got this set up, you could use the E activity. So that is going to give us 12 squared, take away 5 squared, it's 119. So h is going to be the square root of 119. So root 119 is, let's call that 10.9 meters, and it doesn't say how many decimal places, so I'll just give it to the one decimal place and I state that. If the foot of the ladder slips back 2 meters along the ground, determine the vertical distance that the ladder has slipped down the wall. So what we're saying here is that now this is 7 meters. It's gone 2 meters further. Of course, the ladder's still the same length. I'm going to call this distance x from here to here. What we're actually after is the distance it's slipped down. But if I calculate x, this distance here will just be h minus x. So x squared plus 7 squared equals 12 squared. We don't need to go through all of that working again. So we know it's going to be 12 squared minus 7 squared. So 12 squared minus 7 squared is 95, and then we'll want the square root of that. So that gives me 9.7. Now, to avoid inaccuracies, I'm not going to use my rounded figures. I'm going to do this one, take away this one, and then round that. So that is going to be 1.16 meters, correct to 2 decimal places.